Hello. Okay. Up to number 200. This is a big milestone. And let's get going. Is it going to be more Bash? No, it's more SQL. Surprise. Number 196, delete duplicate emails. Difficulty easy. Oh, okay, so we're not just querying anymore, now we're taking actions. We've got table person with ID and email. ID is the primary key. Write a solution to delete all duplicate emails, keeping only unique emails with the smallest ID. For SQL users, please note that you are supposed to write a delete statement and not a select one. For Pandas users, please note that you are supposed to modify person in place. After running your script, the answer shown in the person table. The answer shown is the person table. The driver will first compile and run your piece of code and then show the person table. The final order of the person table does not matter. The result format is in the following example. Okay. So, delete. And then you don't say which columns because you're just deleting. Then you just say from person where something. And then let me just let me just test a few things because I'm not familiar with how to do delete statements. So this worked. I managed to delete everything. So what I want to do is basically select the duplicates and then wrap that in a delete. So where ID in basically, and then I can make a regular query for the IDs to delete. So this is going to be select ID from person. Or you know what? I can do not in and then select the and then group by ID, right? And I said not in out loud, but then I typed in and not. And do I need an order by? And does it need to come first? I'm not sure. So I want to test just this query if I can. Well, this is what I want, right? I want... Oh no, wait, I'm returning John. Sorry, I meant to group by email. Select ID email. And I'm not allowed to... Well, what if I group by email and then ID? Then it makes the group too big. This is so annoying. I haven't figured out how to do group bys properly still. Because yeah, you can't order by email. But if I group by email, first of all, it's not even working. I don't even understand that. Why is it not grouping by email? Is this because I need the order by email? And I need the order by first? Oh, wait. It might be working, it's just that the output that's being displayed here is not the result of this. It's the full table list after it's done, because that's what it said it would do. Because you're supposed to be doing a delete. So that's gonna make this hard to test. The thing is, I need I need an ID at the end of this. But it's not gonna let me do that because you can't select something that you didn't group by. But if I put ID here, then it's not gonna group them correctly. Yeah, it's not gonna... I wish I could group by and not... and just select the IDs. I'm actually kind of confused about what group by even does. Because if you can't select stuff after grouping, then how is it different from select distinct? I guess I could try doing a select distinct. Because I can say what needs to be distinct, right? I can say... how do I say this? It's like... email should be distinct, but select ID. This is so hard without being able to run test queries. I could run SQL locally, but I don't have all the right stuff installed. Is this returning email and ID? Or wait, I didn't... Now it is, but... Like, could I select ID out of this? It's a valid query. This is so silly. I just want to group by email and then take the ID from each of those groups. I guess I don't know why this is not working. I'm really trying not to just Google this time. I should have enough information to do this. It's so tough without printing the subqueries, though. Where ID not in. I really wonder what this is returning. What if I delete the IDs where it is in? Will that help me see what I'm doing? It thinks every ID is in here. But I can't print the emails. I guess I can do this, but that's... Yeah, of course it thinks every email is in there. Okay, so this is returning every ID. After you group by email, you can't choose any other Person.id must appear in the group by clause or be used in an aggregate function. Well, how about first? Is that an aggregate function? No. What about min? Shouldn't this be selecting the minimum ID for each email? Which means not every ID should be in this list? Is it a problem with my group by? Do you need to order by? You have to order by after group by. I don't know why this wouldn't be working. Why would this be returning every ID? Ugh, this is gonna drive me crazy. It's not because this select ends up grabbing everything. Like, I do have a redundant nested virtual table, but I don't think it should. What? That mattered? But that wasn't doing anything. Okay, I don't get it. Submit. Okay. Alright, how did people do this for real? Okay, so you do I don't know what using means. I'm guessing this is a full outer join. Which means you're gonna have every pair of emails represented, and whenever one is higher than the other, that means you can delete the one that's higher. Oh, maybe using is how you do a join when you're doing a delete. So you can always delete the ones that are higher than others with the same email. Okay, so you can't do this actually in Postgres. And this person posted my exact solution character by character. Cool. Window function, that's the other one I wanted to see. Okay, my exact solution. Show me the window. Nope, this is the same thing again. Window me. Where ID not in. Okay, it's the same thing. Just using partition by inside and over instead of inside a group by. It's interesting that everyone did this min thing. I guess that the thing I was trying to do really doesn't work. And then why would row number? Oh, okay, so you number all of the duplicates and then you delete all the ones that have a higher number than 1. Yeah, overly complicated. Next problem. Number 197, rising temperature, difficulty easy. Table weather with ID, record date, and temperature. ID is the column with unique values for the table. There are no different rows with the same record date. This table contains information about the temperature on a certain day. Write a solution to find all dates' ID with higher temperatures compared to its previous dates, yesterday. Return the result table in any order. The result format is in the following example. So if you've got these record dates and temperatures, the output should be 2 and 4. So you're trying to find the record-breaking temperatures. So, well, I would have thought that 10 is the highest it's ever been, but I guess you don't count ones, you don't count the first one. You only count ones that are higher than yesterday. 25 is higher than yesterday, 20 is lower, 30... Wait, you don't want higher than yesterday, you want higher than the record, right? No, you just want the one higher than yesterday. Okay. I think we know how to do this with lead and lag will tell us the row from yesterday. So select lag of ID, or how about, oops, select lag of temperature from weather. Window function, lag requires an over clause. Okay, it's an over. So will that, yeah, that gives me yesterday's value. Okay, so let's call that, what are they calling it? They're calling it lag. Now we just do select ID from, and then we've got this virtual table that has temperature, ID, yeah, it's got ID, temperature, and lag. Here it doesn't matter in which table we do the filtering, but let's do it in the innermost one. Where, actually it does matter because it's not gonna let me talk about lag, right? Unless I do having. Having, temperature, and then let's try to spell it properly, as hard as that is. Greater than lag. As lag. Where temperature is greater than lag. Now they're really gonna make me do 3 nested queries just to... And it's not gonna let me define this inside the where or having, right? No, okay. 3 nested queries. So the inner one does nothing. The outer one says, actually you only need 1 nested query. Select ID, yeah, where temperature is greater than lag. Submit. Wrong answer. Wait, so sometimes you are supposed to return the first day? I guess I don't understand the problem. Why didn't we return this? Write a solution to find all dates ID with higher temperatures compared to its previous dates yesterday. So why is this expecting 1 when there is no previous date? But sometimes it doesn't expect 1, like in this example. These dates are in the wrong order. Okay, we just need to order by record date. Can I do this? Okay. Wrong answer. I said ID 2, it expected no IDs. What? But ID 2 is hotter than ID 1. Oh, this doesn't count as yesterday. Oh, okay. Okay. Where temperature is greater than lag and lag equals, or record date equals lag +1. I don't know how to do date arithmetic on in Postgres. So it doesn't have a record date. Why? Because that's not one of the things I'm selecting in the inner thing. And since this is everything, we'll just do a select star. No operator matches the given name and argument types. So what is record date? Description. It's a date. So I have to figure out how to do date comparisons and stuff in Postgres. So let's look that up. Postgres date comparison. You can do equal, you can do greater. You can do between. Now can I do date like addition plus interval 1 day? Okay. Equals lag plus interval 1 day. Does not exist integer plus interval. It thinks lag is an integer, huh? Oh yeah. That's fair. This is lag temp, and this is lag date. And I want temperatures bigger than lag temp. And I guess they've been using whatchamacallit case, camel case. Lag temp, lag date. Okay. Cool. Can I combine these nested tables? No. I might be able to put this where in this table. Can I do halving to get it in there? No, the fields just don't exist yet. Okay, so this is as good as I know how to do it. Yeah, let's take a look. Solutions. Cross join. Yeah, that's interesting. Like, I get why that works. You're joining everything with everything and saying, but I only care about the ones that are 1 day apart. And the funny thing is, that might actually be efficient in Postgres. It just seems horrible as a, Python programmer. Because that's like doing, we're considering, if we actually had the nested for loops and then an if inside, that would be horribly slow. But obviously, just because you say this is my query doesn't mean that that's how Postgres is going to execute it. Because it can read this and say, well, there's very few rows where this equals this. So we're gonna do something smarter to look at those rows. And did this end up being fast? They don't say. But that's cool. And this is similar. Where exists something where the give me all of the current days where there exists a different day that has the right conditions. That's interesting. This is a more concise way to talk about it, I guess. Whereas here we're saying like sort them and then give me the ones where the one the day before was in fact yesterday and the one the day after is in fact, or no, just the one the day before was in fact yesterday. Anyway, next problem. Number 198, and we're back to regular programming. Number 198, house robber, difficulty medium. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Okay. Adjacent houses. Okay. And then so we're only robbing tonight. So every time we rob a house, the two adjacent houses become off limits. So everything kind of depends on each other in a way that makes it hard to see how I could do better than try every combination. Because with these kinds of problems, it's like, is there... The base thing you can do is recursion. For each house, you either rob it or don't, and then recurse on the rest of the houses. Then, if there's some structure to the problem, you could do better than that by not considering every option. For example, by greedily picking the biggest house. First, and then not considering the option of not robbing that house. And there's situations where you would do that, but it kind of depends on everything. It's like, even if house number 1 is 10 times bigger than house number 2, if you can't rob house number 2, actually, is that right? So you've got all these houses. Let's say this one's really big. If I'm allowed to rob this house, or the thing I'm trying to decide is there a chain reaction to deciding whether or not to rob this house? So if I rob this house, that means I can't rob this house. So the way there could be a chain reaction is if Like, I have some other solution in here that would be slightly bigger if only I could also rob this house. However, I am noticing that you can do dynamic programming here. Because the answer to should I rob this house is this plus this, that would be the score. So is this plus this better than don't rob this house, which means you can rob this instead. Okay, so let's do dynamic programming. Here's our DP table. There's going to be one entry per, are these all positive numbers? They start at 0. So let's do 0 times len of nums. That's how many entries are in my DP table. That's actually one more than you need, I think. Well, let's get it right then. -1. At the end, we're going to return dp of len of nums -1. No, we're going to return dp of 0. Then for I in range len of nums, we want to start with the big numbers, so reversed. Nums of I is equal to not nums of I, dp of I. So the amount that I can rob here, if I bring this back for illustration, the amount I can rob here is equal to myself plus these. So is equal to nums of I plus dp of I plus 2. Or just dp of I plus 1. Whichever is bigger. So dp of I means how much can I rob starting at I to the rest of the list. Okay, and then what's our base case? The base case is in the last slot. Wait a second. Yeah, okay. Wait. No, it's all good. The thing I kept getting confused on was am I forgetting to consider the case that I can't rob the house on the left? But I'm not. Okay, so base case, the thing at the very end, so dp of len of nums minus 1, that's going to be equal to nums of, and guess there's a better way to do this in Python, and that's called negative indexing. So dp of -1 equals nums of -1. Because we have to do dp of I plus 2, we're saying this plus this. I also want to not go all the way to the end of the list, and set that as my second base case. So dp of -2 equals, and did they give us a promise on how many nums there are? Okay, so I need also a if len of nums is less than or equal to 2, return max of nums. So you can only rob one house. This is an edge case. Return whichever house you can rob that's best. Okay, then the before, so this right here is similar. You just say return the max of those two. You can only rob one of them. Max of nums of -2, nums of -1. Is that it? Index out of range. Even though I have the -2 up here. What is my I? What is my DP? My DP table's not big enough. I guess I shouldn't have done the -1. Okay. All right, let's submit. 1 millisecond. No way, Jose. We want 0 milliseconds. There we go. Beats 100%. Okay. I kept getting nervous that I was not actually considering the direction going left, but I was. I was always leaving myself enough space, even though I was only leaving myself enough space on the right. It accounted for both directions. Okay, cool. Next problem. Number 199, binary tree right side view, difficulty medium. Given the root of a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes that you can see, ordered from top to bottom. Oh, standing on the right side. So you would see the fully right path, and then you would also see stuff that's deeper, but not on the fully rightmost path. Another way to say that is you would see the rightmost element of each level. So we saw how to do the level order traversal stuff in previous questions. What are we trying to return? The values of the nodes you can see. Okay, so you basically, we're gonna start with a list. We're gonna do a tree traversal. I think you do have to do a full tree traversal because you have to know if something's going to be really deep somewhere on the left side. So you do have to traverse the whole tree. Def traverse node, tree node, or tree node or none. It doesn't matter what order we do it in. Well, it kind of matters. So let's do traverse node.left, traverse node.right, and then visit ourselves. That way, if we're overwriting stuff in ret, we end up with the rightmost thing last. We want to keep track of depth. And then on the outside, we're going to say traverse root 0. Return ret. So as we're traversing, we're going to be building our tree. Yeah, and we're always visiting the right sides last, so we can always overwrite stuff. So if len of ret is less than depth, ret dot append node, else here. That's true. I do have to say, plus we go down by 1 each time. And I need to handle the base cases. If not node, return. But that's why I have this. I need a less than or equal, I think. Type error. Wait, what's the type error? Oh, it wanted integers. Okay. So don't append node.val. And same here. And something that's bothering me a bit, do this and then you can append, it doesn't matter what you append, just make the list bigger. How can we be out of range if I've just made the list bigger? Or how about I do a while? Okay, so the way we could be out of range is if we go left, if we go down left a few. So just always make sure the list is big enough, and then always replace it with the rightmost thing because we traverse right afterward, after doing left. And we save just one element per depth. Okay, submit. Good. 0 milliseconds beats 100%. Can't do better than that. Next problem. The big 200. Number of islands. Difficulty medium. Given an m by n 2D binary grid which represents a map of ones, land, and zeros, water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. Okay, so there's going to be at least one island. It's impossible to not be part of an island. Because the whole thing is surrounded by water. I just want to know how many there are. So I can just do a tree traversal, or not tree, a graph traversal. Starting at the first one, so just go from top left to bottom right. Whenever you encounter a 1, flood fill it, and then keep going. Once you get to the next one, flood fill it. Once you get to the next one, flood fill it. Each flood fill should take n squared time. Where n, or is this a square? It would take m times n time. And the outer loop will take n times m time. But the overall runtime will stay n times m because the flood fills don't repeat. Like once you've flood filled something, it's flooded. So you're not going back over the same islands. So am I allowed to modify my input grid? It makes it easier if I can, so I'm going to, even though, you know, depending on the actual point of this function, you might not want to be modifying the input. You usually don't want to be modifying the input, but let's do it. So for I in range len of grid, for j in range len of grid, of grid of 0. If grid of ij equals 1, it's a string 0 and a string 1? Yeah. Then we flood fill. And we increment our count. Count equals 0. Count plus equals 1. Return count. Yeah, okay. Okay, then how do you flood fill? I'm gonna call a function here to make it less indented. Flood fill, you need an I and a j. You don't return anything, you just modify the grid. So we want to keep a visited set. You know, we don't actually even need a visited set because we're going to be modifying the grid as we go. So you just say grid of ij equals 0. And then the basic thing you're going to do is call flood fill on all the neighbors here. So +1, -1. And then if I is within the bounds, so less than len of grid. Or I want to exit early here, so I want to say if I is less than 0 or I is greater than or equal to len of grid, or then this if is going to get hard to read, so I'm just going to call this skip. If skip, return. So you're out of bounds on I, or you're out of bounds on j. Or grid of ij is already water. Otherwise, you flood fill all the neighbors. This is it. Submit. Wow, look at that. We're on the left of the tall peak. There's all this peak that's even better than us. I wonder where our variance puts us. Maybe this whole peak is just variance? How could we do better? So obviously this is O of m times n. And it's the space is debatable. I'm not using any extra space, but I am using the space provided to me. So how could I do this better? I don't know. I mean, I can't do it asymptotically better. You have to look at each grid piece. So this is algorithmically the best solution. To make it better in practice, I don't know. I don't really have any ideas. I'm like, one thing usually that helps is to unroll recursion into loops. So you'd have to have like a queue of things remaining to visit. It wouldn't make a big difference though. I think. I don't think it would make a big difference. So yeah, this is about as good as I can think of how to do it. And I got it on the first try, which is great. That's the power of solving 200 Leetcode problems. So did anyone do anything significantly better? This is exactly what I'm doing. Exactly what I'm doing. What makes it faster? They're checking the conditions before recursing. That makes sense because I'm checking both I and J. But I already know that either I or J is good. Yeah. All right, well, that's it. Thanks for watching. If this was helpful, please leave me a like on YouTube or Leetcode. Peace.